Hey there, science fans! Today, we're diving into the exciting world of exponents. Exponents are a shorthand way to represent repeated multiplication. They're like those handy shortcuts you take on your bike. They make the journey quicker and more efficient. Let's say you have 2 multiplied by itself 4 times. 2 times 2 times 2 times 2. That's a mouthful. Instead, we can write it as 2 raised to the power of 4, which looks like this, 2 to the 4th power. The 2 is called the base, and the 4 is the exponent. Exponents pop up everywhere in math and science. They help us calculate huge numbers like the distance to stars or the number of atoms in a grain of sand. They're essential for understanding things like population growth, radioactive decay, and even the spread of a virus. So, buckle up and get ready for an electrifying journey as we explore the amazing properties of exponents. Now that we're familiar with exponents, let's see what happens when we multiply them together. Imagine you have 3 squared multiplied by 3 to the 4th power. Using what we've learned, we can write this out as 3 times 3 times 3 times 3 times 3 times 3. That's a total of 6 3's multiplied together, or 3 to the 6th power. Notice something interesting? When we multiplied exponents with the same base, we simply added the powers together. 2 plus 4 equals 6. This is called the product of powers rule, and it saves us a ton of time and effort. Here's another example. 5 to the 1st power times 5 to the 3rd power equals 5 to the power of 1 plus 3, which equals 5 to the 4th power. Remember, the product of powers rule only works when the bases are the same. So next time you encounter multiplying exponents, don't sweat it. Just remember to add those powers, and you'll be good to go. Just like we can multiply exponents, we can also divide them. Get ready for another handy rule that simplifies things. Suppose we have 4 to the 5th power divided by 4 to the 2nd power. This can be written as 4 times 4 times 4 times 4 times 4 divided by 4 times 4. Notice that 2 sets of 4's cancel out from the numerator and denominator, leaving us with 4 times 4 times 4, or 4 to the 3rd power. What happened to the exponents? When we divided exponents with the same base, we subtracted the powers. 5 minus 2 equals 3. This is the quotient of powers rule, and it's just as useful as the product of powers rule. Let's try another one. 2 to the 6th power divided by 2 to the 3rd power equals 2 to the power of 6 minus 3, which equals 2 to the 3rd power. Again, the quotient of powers rule only applies when the bases are the same, so fear not division with exponents. Just remember to subtract those powers and you'll conquer those problems in no time. Section 4. Power of a power. When exponents stack. Hold on to your hats because things are about to get powerful. What happens when we have an exponent raised to another exponent, like 2 to the power of 3, all raised to the power of 2? Let's break it down. 2 to the power of 3, all raised to the power of 2 means we have 2 times 2 times 2, multiplied by itself twice, 2 times 2 times 2, times 2 times 2 times 2. This gives us a total of 6 2's multiplied together, which is 2 to the power of 6. Did you spot the pattern? When we raise a power to another power, we multiply the exponents. 3 times 2 equals 6. This is the power of a power rule. And it's like a turbo boost for exponents. Here's another example to solidify the concept. 5 to the power of 2, all raised to the power of 4 equals 5 to the power of 2 times 4, which is 5 to the power of 8. So, when you see those exponents stacking up, don't panic. Just remember to multiply them and you'll unlock the power within. Section 5. Powers of products and quotients distributing exponents. Sometimes, exponents like to team up with products and quotients. Let's see how they play together. Imagine we have 2 times 3, all raised to the power of 2. This means we're squaring the entire product. 2 times 3 times 2 times 3. We can rearrange this as 2 times 2 times 3 times 3, which equals 2 to the power of 2, times 3 to the power of 2. Aha! When we have a power of a product, we can distribute the exponent to each factor inside the parentheses. The same goes for quotients. 2/3 all raised to the power of 2 equals 2/3 times 2/3, which is 2 times 2, divided by 3 times 3. This equals 2 to the power of 2, divided by 3 to the power of 2. Remember, distribution is key when exponents join forces with products and quotients. Section 6. Zero and negative exponents special cases. We've covered a lot of ground, but there are 2 special cases of exponents we need to address. Zero exponents and negative exponents. Any number raised to the power of 0 equals 1. Why? Think of it this way. 5 to the power of 2 divided by 5 to the power of 2 equals 5 to the power of 2 minus 2, which is 5 to the power of 0. But we also know that any number divided by itself equals 1. Therefore, 5 to the power of 0 must equal 1. Negative exponents are a bit trickier, but still manageable. A negative exponent means we take the reciprocal of the base raised to the positive opposite of the exponent. For example, 2 to the power of negative 3 equals 1 divided by 2 to the power of 3, which is 1/8. Congratulations, science explorers. You've mastered the essential rules of exponents. Keep practicing, and you'll be solving complex equations like a pro in no time.